For the people who chose to stay, I promise you, your minds will be blown. So you'll be proud you stayed. Just read this title. This sounds like an oxymoron, but trust me, your mind is about to be blown. Yeah. Okay. Cool. They were going to introduce me, but fine. I don't need no introduction, anyways. Doesn't matter who I am. I'm a DevRel engineer with Agoric. Anybody ever heard of Agoric in here before? Okay, awesome, awesome. Got a few fans. Awesome. Okay, so today we're going to be talking about this very interesting statement, writing async cross-chain smart contracts. And for those, how many in here are developers? How many write code? Okay, a few people. Okay. How many people know Solidity out of you guys? Solidity? JavaScript? Yeah? Okay, cool. We got some JavaScript engineers. Perfect. All right. So as you know, as some of you may know, with smart contracts, this notion of being asynchronous is like a parlor trick because contracts are supposed to be transactional or atomic. They run or they revert. They run to completion or they revert. And when you start thinking about asynchronicity in a smart contract, the first thing that comes to you is like, whoa, what is that about? But here's what we'll talk about today. So the first thing we'll talk about is, or also you have access to the slides if you're interested. So you can just go to our GitHub, like Agoric SDK discussions, and it's the last discussion on there. So today we're gonna talk about your first orchestration contract, which is a cross-chain unbound example. Then we're gonna do a deeper dive into another contract example of cross-chain swaps, and then we're going to retrospectively go through some foundations to clear some gaps there. Yeah? Okay. All right. So the first section, your first orchestration contract. Let's start with the use case. So we want to liquid stake some bonded TIA. TIA is a native asset on some blockchain, right? And we have that already in our possession, and we want to liquid stake that on another chain. Okay, so there's a few things that we have to do here. So the first thing is we have to undelegate. Anybody not know what a delegation is? It's okay, don't be shy. We'll explain it. So in proof of stake chains, when you delegate, you bond your tokens to a validator. So first thing is we have to undelegate those, right, on chain A. That requires me to sign one transaction. And there's gonna be code, there's gonna be a lot of code in this talk, right? So I'm just giving you the use case so that we start on the same ground. So I first have to sign one transaction, right? And count how many signatures or how many signed transactions we have to do. So I approve a transaction and I have to wait. For those of you who don't know, in proof of stake chains, when you unbond, a way that, for a security mechanism, there's a period that you have to wait, 14 to 21 days, usually. So that means I have to sign a transaction, wait 21 days, then I have to do another transaction to actually transfer the result of me unbonding, right? So when I unbond, I get my tokens back. Then that means I have to sign a second transaction, okay? Then I have to do a third thing, which is actually invoke this native functionality on that other chain. And you guessed it, that requires a third signed transaction. So 3 things I have to sign, but this thing is a big issue too because I have to wait. And you go back to what I said in the beginning, contracts don't wait for things to happen in the world. Okay, so you can read that statement. I'm not going to read it out loud. This is not an easy thing to do. Okay, code. Let's look through it. So this is just a function. We'll kind of retrospectively go through these things throughout the talk. But the first thing we're doing is we're going to, like we said in the walkthrough of the solution or the problem, we want to get how many delegations we have on that other chain. Okay. This is a call that I'm making. This is a cross-chain call that I'm making that I'm waiting to come back, right? So one thing to easily miss here is, for those of you who know JavaScript, this await thing is magic for us, right? Because this is a promise that I'm then waiting to be resolved. But that happening in a smart contract doesn't exist. So this is making a cross-chain call to get some information. Then this right here is actually submitting an undelegate request, right? But remember, this for this promise to be resolved, this is going to take 21 days. But I'm doing that in my contract. Then, and this is the beautiful thing about, and what's funny is I didn't even introduce Agoric, but Agoric, that's so funny, I jumped right into this. Agoric is obviously a blockchain, but we have JavaScript contracts. I should have said that in the beginning, but you can infer that here. But the point is, once this promise is resolved, execution is going to continue. So the fact that we're using this JavaScript primitive of async and await and a promise inside a contract to manage control flow of my program is, without going too deep into it, is phenomenal. It's actually groundbreaking in my personal opinion. So I'm biased. But as I continue, let's say I wait 21 days, this is done. Now I'm just gonna get a chain object for this other chain I have to go to. Then what I'm gonna do is I'm gonna make an account on that other chain. Then after this resolves, I'm gonna then again query some data. Then once that comes back, I'm going to issue a cross-chain transfer of the amount that I just got as my balance on that first chain. Yes, I'm doing a transfer to the account that I just made. That's key. Then I'm invoking some native functionality. This seems like a very trivial example, but this is very much a magic thing happening. Is this confusing for anybody so far? Because this is just the third slide. Perfect. And feel free to interrupt me. We have a small group here. Okay, so now let's retroactively look at what we just saw. So in Agoric, we have these concepts that we kind of are helping people understand, which is a framework for orchestration. So we have this notion of an orchestrator. We have this notion of a chain object, which you just saw. We have this notion of an orchestration account. And the way you can think of an orchestration account is think of it as an abstraction, because you have two types of accounts. You have an account on the local chain, Agoric, and you have an account on another chain. So if you bring a higher level of abstraction, you have this abstracted idea of an orchestration account. Anybody ever heard of this? An interchain account? Okay. For those of you who don't know what an interchain account is, well, we'll get there. So interchain account, high level, is just a way for it's a way for a blockchain to control an account on another chain. Think of it that way. Very, very simple way to say. So let's look at the interface really quick. And you've seen some of these in the last thing. So you've seen get chain, right? But this interface, we allow the orchestration API allows people to the orchestration interface, I should say, allows you to get chain, make a local account, get brand info, and this as amount, which is just a convenience for conversion. In this chain interface, remember I said that we abstract this idea of an account, right? We have a local account and a remote account, but now we just have this high level abstracted version of it. So we can kind of treat them the same way, even though there might be some subtle differences under the hood. So on a remote implementation and a local implementation of an account, we can still invoke these functions like make account, get chain, but then we can also invoke chain-specific functionality. Making sense so far? Anybody confused? Okay, good. If you don't say you're confused, I'm assuming you're not. So, don't be shy. Okay, so the orchestration account interface, we can get address, get balances, we can do sends, we can do a single send, or we can do a series of sends. Pretty simple. Okay, this is going in deeper into what ICAs are, right? But I kind of explained that to you. But if you're really interested, look into this specific spec, ICS standard 27. So I mentioned to you that it's a way for one blockchain to control an account on another chain. But when you combine it with Agoric, the contract that's creating that orchestration account has sole access and control over it. This is key. Okay, so we've shown you this already, right? But now we're reminding you what you just saw, because you saw it in practice. We explained the concepts, and now you're seeing it again. Now, so the previous slide is like the meat of that orchestration logic, right? But this is the area around it. This is what's wrapping it, if you will. So if you go back, you see this function right here is pretty much handling this orchestration, right? Or it's its handler. But you see what we're doing is, and we'll explain some of this stuff, but you see that function here. And so we'll kind of explain what this is. So you see us using something known as a zone, and we're making an exo from that. And we have this thing known as an invitation. I'll explain what this is right here. Have this notion of harden. You have these things here, right? But what I'm showing you here is this is really boilerplate. When you make an orchestration account, this is how you will set it up. And your magic for your specific use case will be in the body of what's this is actually using. Is this making sense so far? Okay. So let's look at a second example and dive a little deeper into some of these concepts that I just explained that you've never seen before. So the first thing is, what is an exo? Enjoy that picture. Think about, well, this is an exoskeleton, right? What's the purpose of an exoskeleton? To protect the person on the inside, right? So you can think of this exoskeleton part as an interface guard, something that's a protective layer, protective outer layer, and you could think of the insides as being protected as some methods, okay? And look at it this way. You saw us use a zone before. You saw us do this zone.exo. What a zone is used for is to allocate exos. And we have this convenience here for like make a durable zone. And when we say durable, we're just saying some type of information that can survive a contract upgrade. So like if you are making a new version of your contract and your contract was already doing some stuff before, some of the information that your contract was using, you want it to survive through that upgrade. So we call these things durable. Now, if you go back to remember I said that the methods are the inside of the exoskeleton that's being protected. This right here is what we call the interface guard. So what this is doing is it's actually protecting the method from being called by validating input and also validating output that the method returns. And these are the functions that these interface guards or this interface guard would apply to. This is a visualization of this, okay? So let's walk through it. Some users' code wants to invoke a method using some asynchronous way, which we'll talk about. What the interface guard is first going to do is verify the method signature, similar to an interface in regular programming, right? An interface in regular programming, anything that implements that interface, the interface is going to ensure it implements it correctly or adheres to it. If the interface guard is happy, it's actually going to make the method call. Then method gets called, it's going to return it. The interface guard is going to also verify the return. Then if the interface guard is happy, all continues. So how you create exos, we already showed that, but you define your exo here, you specify how you want to handle inputs and outputs, and then these are the functions that it actually applies to. Make sense? Anybody lost? Okay, good. Proud of you guys. Okay, so now let's talk about this all-chain service that actually allows us to write contracts with some safety guarantees. This is what we call Zoe. So you could think of Zoe as a on-chain service that provides a way to write smart contracts that adhere to something we call offer safety. And so the components of Zoe is like an offer, a proposal, an invitation, and a seat. And we'll walk through what these are. So Zoe, like I said, is a service, right, that helps us writing contracts that adhere to this offer safety standard. Let's walk through a flow of here, though, so a Zoe flow. So you have two parties and a smart contract. These two parties want to make a deal. So these two parties, the first thing that they do, oh, see, this happened yesterday, but there's a box right here that says Zoe, I promise. It's on my computer, but resolution things, color, whatever. There's a box right here that says Zoe. The parties, what they do is they first escrow their assets into Zoe, okay? So Zoe serves as an arbiter, an enforcer of safety. So you escrow your assets into Zoe, then the parties communicate with the smart contract. A key point here is that the smart contract never gets assets. Okay, Zoe maintains that as escrow. So parties communicate with the contract does some custom stuff. Then the contract tells Zoe that, hey, everything is good, reallocate these assets. Reallocate simply means if you have Zoe that has these assets given by person A and person B, Zoe can then do this, swap, in a safe way. And remember, the contract still, it never gets assets. And so the last thing after reallocation, the smart contract tells Zoe, hey, everything is good. Okay, you can finalize the offers. Then the last thing all Zoe does is it allows the parties now to withdraw their payouts from the deal. So the whole time the contract never gets assets, Zoe is that escrow, Zoe is that enforcer of something we call offer safety. So another thing that's key is that Zoe, this thing here, runs in its own isolated environment. Away, safe from being tampered by any other contract. That's another piece of security. But this is actually fundamental to Agoric, because Agoric, we have this thing known as a VAT. How many people recognize this graphic right here? You get a t-shirt if you could tell me where it's from. 10, 9, 8, 7, 6. Okay, nobody knows. That's from Mozilla. That's just from the JavaScript docs. One of the key takeaways here is I want you to realize writing contracts in Agoric is literally just you writing JavaScript. It feels like you're writing a Node application, but some magic is happening where all of this magic cross-chain stuff is happening, but to you, you're just writing an application that feels like you're writing Node. Okay, so what does this mean, though? All this is saying is explaining what's the JavaScript environment look like. So typically, you have a heap, you have a stack, you have a queue of messages, and you have an event loop. And the event loop is pretty much what's helping make sure that messages are being, passed around the way they're supposed to be, and things are being listened to correctly. And these are two key pieces here. So all synchronous communication is only within a VAT, like that isolated environment. All communications between VATs is asynchronous, which makes sense because you can think of a VAT as a process on an operating system, right? Like if intra-process communication tends to be synchronous, inter-process communication tends to be asynchronous. Not purely, but okay. Make sense? Okay. Remember, ask questions as we go. Lunch is after this, so you have time to ask questions. Okay, let's continue through this. So also core to concepts for Zoe is this notion of invitation. And the invitation, it's key because currently you use invitations to invoke a contract. And so if you don't have an invitation to invoke a contract, you just can't do it. And you can get the way you get invitations is programmatic, right? You can specify how an invitation is given from your contract. But another key thing here too is that invitation is also a payment. So you can treat an invitation like an asset, which is a bit of a new concept, but it allows for some very interesting use cases that can come from that. For example, if I got an invitation to participate in a contract, I can then give that to somebody the same way I would give them an NFT. So imagine if I gave you an NFT, which gave you the opportunity to invoke a contract somewhere. That's not seen commonly. Okay, okay, that's good. So in programmatically, okay, let's start here. So here what I'm doing is I'm asking Zoe to give me a way to talk to this specific cross-chain unbound contract instance somewhere. Then what I'm doing is I'm using that way to peer into that contract instance I'm invoking it in an asynchronous way to invoke this method that's then returning for me an invitation to trade. It's an invitation to trade. Then what I do is I invoke Zoe again to submit an offer with this invitation to trade. Notice the nomenclature I'm using this proposal. And so we'll walk through what a proposal is, because similar to like making a deal, when I am talking to a contract, I make an offer to it, and in that offer contains a proposal. And so, and we'll kind of walk through what this means here, like why the proposal is that way, etc. Like why it's structured that way, I should say. Okay, one more thing here. So this notion of a seat, let me see, we go back. Okay, we don't have code on here for seat, actually. Let me see. Okay, I think it might be next slide. But high level, you can think of it this way. In the function that's being handled, that's handling the offer that I give to the contract, one of the parameters is a seat, and that seat allows me to get some useful things of what's of the deal that's happening. Think of it this way. And so we have two different type of seats that really represent two views of the same seat. So you have a ZCF seat, which is used inside the contract, like in the actual offer handler. And then you have this user seat where, notice here on this previous side, when I ask Zoe to submit this offer for me, it returns a seat to me. And this seat, I can then use it to do some subsequent things. Like, remember how we showed the graphic of, at the end, Zoe allows the parties to get payouts. this is how you would do it, right? But this seat, this is the user seat, because this is not inside the contract, even though you can have another contract that's making these calls, right? But the ZCF seat is happening in the contract that's being called. Okay? All right, so just to go back, remember, these are the concepts for orchestration, and we're going to go through the second example now. So remember, we have orchestrator, chain object, and these abstracted orchestration accounts. So this is the second example. Let's walk through this a little slowly. So remember, we mentioned this idea of a seat. This function is what's handling this offer, or just think of this function as a handler in general. But see, I'm getting this seat here. So now with this seat, I can get the proposal in the offer. And see, and then we're getting a chain object for this specific chain object for Agoric, which is the local chain. This is key because remember, this is the remote chain type. This is a local chain type. Then just making sure all these promises resolve. But what we're asking for is we're asking for these chain objects to make an ICA for us, an interchain account. Then we're getting the address here. Then what we're doing is we're withdrawing. So okay, let's go back up top. So here, when we're getting the proposal, in the proposal, we have this field for give. And what this is showing is this give is what the entity that made the offer is willing to give in the offer. Remember, with Zoe and the reallocation of assets, you have something that you want to give, you have something that you want to receive. And so all we're doing is referencing the proposal to get what the entity wants to give. Then we're withdrawing that from the seat that's passed through the handler. Then what we're doing here is this is just, for those familiar with like deep equal, this is just making sure that all of the properties in this are if they're promises, they're being resolved. And then this is just iterating over properties of this object here. And so what we're doing is we're depositing these payments into the local account that we make up here. Into the local account that we make up here, this Agoric make account, okay? Then we're exiting the seat. So like you say, think of it like a deal. I'm exiting the ZCF seat. Then what I'm doing is I'm preparing my cross-chain swap now. So if you notice, what I'm doing is I'm saying, what's the destination chain? And mind you, this is all happening in a contract. I have to keep saying this. I'm specifying what the destination chain, what's the destination address, what's the asset that I want to give in, what's the brand that I want to give out, and we'll talk about what a brand is, and slippage. Then what I'm doing is I'm executing, this allows us to execute a series of transfers. And this is also a magic thing, because remember, I always skip over these awaits, but remember, these are cross-chain calls that's happening. So it seems like I'm just walking through some logic that's all happening right here, but this is cross-chain stuff happening all by magic of async and await. But what this is saying is after these transfer steps are done, I'm going to make a delegation on this other chain. So essentially, I'm swapping assets from chain A to chain B, and I'm delegating on chain B after these promises are resolved. Making sense? Anybody have questions about this? Because this is new stuff. So don't be shy, okay? All right. I'm proud of you guys. So once again, this is boilerplate, right? And essentially, what you're really seeing is this part right here is changing. I'm just specifying what's the newer function, right? This is a whole nother contract, right? I just want to remind you, this is boilerplate and shouldn't change much, right? I mean, you can start changing stuff, obviously, like what type of proposal you expect with the invitation when it's used, but it's up to you. Okay, so let me go back. So if you notice, we have these things called harden here. We haven't talked about that yet. So let's walk through what is harden. This refers to something known as hardened JavaScript. So how many people know JavaScript in here again? I think it was a few, okay. So with JavaScript has this very existential issue where I can clobber things, right? So here I have this object that's being returned, has these properties, and after I get it, I'm just overriding this. And in traditional JavaScript, I can make this whatever I want. But the difference is if I return a hardened object, I can no longer tamper with it. It's going to now throw an error. right? And this is a security thing. And if you're really interested into it, you can look into what this object.freeze is doing. What it's doing is it's just making sure the properties of an object can't be changed. And so this brings us to this concept of a proposal, which you've seen a few times. But let's help you understand what it is. So proposal has these three properties: give, want, and exit. We talked about what give and want is. If it's a deal, here's what I want to give to you, here's what I want in return. We didn't talk about what this exit criteria is, though. What this exit criteria is doing is it's defining how and when an offer can be canceled. So you can do it where this exit is on demand, where the person who made the offer can cancel it. You can also do it where it's time-based, where after a specific time it's canceled. And you can also waive the right to exit, making sure that the contract controls that. And you talked about offers several times, but just to wrap this up and make it concrete in your mind, an offer contains a proposal, an invitation, a payment, and optionally some offer arcs. Okay. And you've seen this already, right? But just to make it a little more concrete, we're making our proposal here, getting an invitation, using the invitation to trade, blah blah blah. This is the second time you've seen this, so this should feel a little familiar now. You know how we're using Zoe to get access to a contract instance, making a proposal, doing all that stuff. Okay. Okay, so now let's go a little more friendly, and some of the things that you've seen, let's help you understand fundamentally what you're actually looking at. So we wanted to, yesterday we did the same talk, and just to be honest, we did it in reverse. And so this time we're giving you the punchline first, and we're walking you through the basics. So maybe this might be the first talk ever where we show you a hello world contract at the end. So essentially, think of it this way. This has nothing to do with orchestration now. This is just the most vanilla contract you can write on Agoric, within reason. So you have this notion of an exported start function here. This returns an object with some properties, and that's essentially it, right? But for those of you who know Solidity or Cosmosm, this start function is your entry point. This is similar to, in Solidity, you have this notion of a constructor, which is popular in many languages, but in Cosmosm, you have this entry point known as instantiate. It's the same deal. When the contract instance is started, what code runs automatically? So this is the most vanilla contract you can write in Agoric. But let's talk about something more fundamental. So actually, let me go back, set it up. So notice, well, people who know object-oriented programming in general, in object-oriented programming, if I give you access to an object, you can invoke any public function on that object. That's just the way access control is kind of defined that way. You have like protected, private, etc. But it's defined at the method. But when you do it this way, if I return, if you think about higher order functions, functions that return functions, that means if I invoke a function, I can invoke, and it returns me functions, I can obviously invoke the functions it returns to me. But this is actually a security paradigm, because if you think about this, think about these entities as objects, right? The key thing is that Alice has access to Bob as an object, and Alice has access to Carol as an object. But Bob does not have access to Carol as an object. And if you think of these edges, think of these as permissions. So because Alice has access to Carol and Bob, what Alice can do is Alice can grant a permission to Bob by sending a reference to Carol directly to Bob. That reference that she sends would allow Bob to invoke something on Carol, like bob.greet Carol. But this approach here ensures that objects can only invoke objects when they're given explicit rights to do so. Does that make sense? Okay. And you can go deeper into that. That could be like a whole talk by itself, which, some people on our team have done. Okay. This is something that we call the electronic rights transfer protocol, and these are some of the foundational concepts in Agoric dealing with like assets and stuff. So high level, we have this notion of a brand. You can think of this as like a denom, if you want to say that, or a certain type of token. But concretely, this represents the unique identity of a type of digital asset. An issuer represents a trusted authority that validates payments for the asset, and a mint, similar in a lot of places, issues new digital assets. One key thing here is that a mint can only issue assets of a single type. That's key. And there's a one-to-one relationship between mint, issuer, and a brand. Okay. And so here we have this. Let's start with asset kind. So asset kind should feel familiar to you. This is it a fungible token or non-fungible token? High level. We also have this notion of an amount. So instead of representing an amount as just a pure integer or number, similar to like in Ethereum, where if you want to make a certain amount of tokens, you just say it's really a number. We have an abstraction for that, which amount is really answering this question of how much, but an amount is an amount you have. We're actually going to show you in code, but amount you have a brand, like which brand is it and how much is really the difference. A purse, you could think of this as a container for holding digital assets of a specific brand. So purses only hold one type of brand. And here, you remember earlier I mentioned to you that invitations are payments as well. So payments is a spendable representation of a digital asset. Okay, each of these can probably deserve a few slides to kind of show you programmatically, but we have talks on that too. So, okay, let's talk about, remember earlier I mentioned you have inside of that synchronous communication, and then we talked about what happens when two VATs talk to each other. Let's look at how that happens. You've seen this used in a lot of the slides here. But for people who know JavaScript, think about how browsers use this convenience for fetch for remote communication. You could think of this as the same way. This is known as the eventual send, but this allows us, this asynchronously invokes methods in another VAT, machine, or wink wink blockchain. And this is funny, a good tidbit. This entire way to build isolated JavaScript environments doesn't have to just run on a blockchain. You can run this on two computers and do the same types of interaction. That's one of the powers about this entire paradigm and framework. Agoric is just bringing that to the contract world, or has brought that to the contract world. So let's kind of build on what we just said. So remember, Zoe runs in its own isolated environment. So if we try to invoke Zoe this way, it won't work. Because remember, this is a synchronous call. So what we have to do is we have to use eventual send, which looks like this. And with eventual send, we're going to get a promise back. And so we can do standard conventions in JavaScript like then, catch, etc. Making sense here? The difference between synchronous and async picture? And the slides are online too. So the slides we did yesterday had way more slides in them. So if you go to the GitHub, you'll get way more slides and it's more fun to look at, I think. Okay, let me go back. So when we're doing this, what we're really invoking is we're invoking what we call a presence of a remote object. So you have these two different VATs. When we invoke this thing, like with E, it's really a presence or representation, a local representation of this remote object. So you can think of it, it's not as concrete, but you can think of it this way, that local presence is serving as a proxy for that remote object. And so if I go back one, it allows you to write it as if it's an object that's in your same environment, and it's treating it conveniently for you without you having to worry about where the object is. Very powerful, very powerful. Okay, and let's talk a little bit about, if you look at our GitHub, you look at our Golang side of our repo, we have this module in there called vStorage. This is how we handle, this is one way that we handle storage. So vStorage, think of it as a hierarchical data storage. So you think about a tree, right? Typically, if you implement a tree, each node has a left and right? But the nodes typically don't have a reference to like their parent. And so if I have a tree and I gave your function a subtree of that function would not be able to traverse, typically, depending on how the data structures are, it wouldn't be able to traverse back up the tree, right? So that's a useful way to think about it, because with vStorage, it's hierarchical, but what I can do is I can pass in a specific node in a bigger tree, think of it that way, and that would mean that the contract can now use that specific node in that tree to store data in its children. okay? But it wouldn't be able to clobber the storage space higher than that node that I give it, okay? So this is actually, let's go to the next one, because it says the same thing. So this is the biggest key thing to take away from this part, the vStorage part. The way we treat storage is very specific. Contracts can only write to vStorage, and clients can only read from vStorage. They cannot write. So let's look at what that looks like. So you have some client somewhere, you have a contract. And so this is actually what it looks like. So I have this storage node of a specific key. I'm going to use E to invoke this set value method, which is going to store a value at this node. That's the contract doing that. Once that's done, a client off chain can now send the RPC query to vStorage, which will return this value. This allows for, you don't have any like synchronicity issues. Imagine if a contract could read or write, right? And many of them doing the same thing, right? It's a different complexity model there. So allowing for this allows for some guarantees where vStorage won't be clobbered. I can kind of talk about that a little more, but hopefully that's helpful. So this is just kind of give you a more concrete example. We're looking at code. So we've seen this already. I'm using E to asynchronously invoke the storage node. I'm making a child node there. Remember, it's a node in a tree. I'm making a child there named metrics. And what I'm doing is in my entry point of my contract, when it's started, the instance is started, I'm using that storage node to make a child node. And then here, this allows to store a value at that node. Pretty simple, pretty simple. This making sense? Anybody confused by that? Good, I'm proud of you guys. Okay, so to wrap this up, you can also do this on a command line because it's a Cosmos SDK module. You could just use our AGD or AGD. So here I can query vStorage for its children or its data. So children would tell me what child nodes are at a specific node. And then this is key too. We could, because it's, when you use these CLI commands, all it's doing is issuing an RPC call anyways, but you could do a raw RPC call yourself using fetch, which our UIs do. So we have templates that have UIs in our GitHub, and they pretty much fetch it that way, roughly. So let me remind you of the use case that we started from here. Remember, several different transactions have to sign, long waiting period. You would not be able to solve this in traditional contracts. Okay, cumbersome stuff. Just remind you, this is what we looked at. This was the first example we looked at. Just remind you, this is a cross-chain message happening. This is a cross-chain message happening. This is a cross-chain message happening. Cross-chain message happening. Cross-chain message happening. But to you, it's like you're writing a JavaScript script, similar to you writing something in the browser. Does this feel familiar for the people who know JavaScript? Okay, I see some nods. Okay, so to recap, here's what we just walked through today. And we have some time for questions if you guys are interested. So we walked through showing you your first orchestration contract, which is a cross-chain unbound, that lengthy workflow. We also walked you through a second example, which is a cross-chain swap. And then we walked you through, retrospectively walked you through some foundations to cover any of those gaps there. So now you guys, see, they don't have the picture, but I'll turn my computer around so you can see it. Picture's kind of cool. It's supposed to be like a conductor here, conducting an orchestra of blockchains and all this cool stuff. But now you have some powers. Now you're one of the first people in the world to know how to do this concretely. And this is a very recent progression in this space. And obviously you see these buzzwords happening around the industry, but this is a really concrete way of doing this. And you are able to play with this today if you're interested. We can help you set up your testing environments. We have a few different ways to do that. But if you're interested, please look at our docs. More importantly, though, if you want to have fun with us, you can come to our weekly office hours, which are on Wednesdays. We run them open to the public. People come, ask us things. If you want to learn some interesting stuff, we would love to meet you there. So you can always go to agoric.com/discord. And yeah, anybody have any questions there? Any thoughts, concerns? Anybody was completely lost throughout the talk? Okay. Well, awesome. Well, I have to say thank you for attending the talk. You could be anywhere here in the conference. We appreciate you, and enjoy the rest of your day. We appreciate you. Thank you.